Okay, good morning, everybody. My name is Dr. James Carton. I'm in the School of Mechanical Manufacturing Engineering within the Faculty of Engineering Computing at Dublin City University. Today, I'm going to present to you a postgrad course around the Masters in Mechanical and Manufacturing Engineering. I'll be presenting for probably about 30 minutes. And then during the presentation and after presentation, I'm happy to take questions. Unfortunately, with the screen set up, I actually can't see questions at the moment, but I will finish my presentation and then look at the list of questions and messages to see can I set up and discuss questions and about the course. So Dublin City University, first, why come here? We're ranked a very high university in the world, and consistently across the statistics about universities, DCU ranks quite high globally. In addition to that, DCU has a lot of innovative activities going on. My area myself in sustainability, and certainly across the sustainability side, Dublin University is leading in a number of areas. As well as that, DCU has a really good support structure for students, both professionally and within the student community. And also from a university side, we're a relatively new campus. We're a young university relatively to many universities in Ireland. And we've got really amazing facilities. Certainly in the engineering facility, you will see the facilities around the labs, around the tech, and around the presentation of what lecturers present to you in the university. So what I would say is why you here. So certainly from the Masters in Engineering, there's lots of opportunities around careers within sustainability, within mechanical engineering, within bioenergy, within biomedical engineering, and effectively across the world, there's many challenges, global, national, and local. And effectively to solve these problems, we really need engineers at a high capable level. Effectively, the career opportunities are really exist within Ireland, outside Ireland, and effectively we need qualified engineers. The interesting thing about the master's programs across Ireland that you might be looking at is that the master's program in DCU, the Mechanical Manufacturing Engineering Master's program, is quite flexible. And I'll go through the modules, I'll go through the structure in a minute. But what it allows you to do is pick modules that you are interested in, that you can select towards the career opportunity you're interested in. And again, that opens up you to exactly what you like, but also you can tailor that to maybe an industry that you're interested in. So the program chairs for the Master's in Mechanical Manufacturing Engineering are myself, James Carton, and my deputy chair is Tomas Schke. And again, just from maybe a chairperson role, the hope is that you would see us on orientation, you would see us generally throughout the semester, but where we really come into our own is where we support you and your activities within your academic and your journey through DCU. We'd hope that any challenge, academic, exam can be managed with us. We'd suggest that generally a module issue, if you have issues with notes or with particular module exam questions, that's actually obviously for the module coordinator. But from a chairperson, we help if you have a challenge with a module, if you miss a module, if you miss an exam, we can kind of help direct you towards paperwork documentation that you might need, And we also support you in relation to access to supports within teaching, teaching and personal and medical and all those supports within DCU. So the structure of the program, and maybe actually I might skip this slide, or I might run over the slide quite fast, but effectively we have a number of entry levels into the mechanical manufacturing engineering. We have we've a qualifier course, so if you are not an engineering degree holder or at that level, you can come in through a qualifier level, and that effectively gets you a number of modules for a year, and then you end up the year after then able to apply for the master's program and join the master's program. If you're from a science technology angle, you can access through the access course, and with those modules, you can again learn for those modules for a year, and at that point, then we see you fit enough to come on to the master's degree, and then you come on to the master's degree at that point. Coming in directly, if you have the correct qualifications at a high level, and you're deemed applicable, you can enter the master's directly, and effectively you can come out, and I'll go into the majors in a moment, but you come out then after 1 year full-time, and then sometimes 2 years and sometimes 3 years part-time students can do the master's degree in. Some students decide to exit early due to personal issues, or really just that they want to exit, and you can exit with a graduate diploma and a graduate certificate depending on the credits you've gained over the year or 2 years with the master's program. And again, I'll go into those exit options as well, because students sometimes are interested in those. So the majors within the master's program are the simulation-driven design, advanced manufacturing, sustainable systems and energy, and biomedical engineering. And the major depends sometimes on your project, or the major depends on your project you've chosen in relation to the master's degree, and also the stream of modules you're taking. So some students select a number of standard core modules, which are across all these majors, but then they might mix and match some of the modules. And the way we look at it is some of those actually may not come out as a major because they may not have the mix that suits either of these majors. So you come out then with you don't come out a major, but you come out with a master's degree qualification in mechanical manufacturing engineering. And we call that a general degree. And then the title of, for example, that you would have on your certificate would be the manufacturing engine or master in engineering in mechanical and manufacturing engineering with a major in whatever degree you've chosen. So, and again, if you've questions, just highlight them, put them in the chat, or keep them for a few minutes. I'll go through the modules, and again, students find that the modules can be interesting for them, or maybe you have questions about the modules. So please ask those questions. So as you'll see, so I'm going to go through these core all the modules here, and then I'll break them into the majors so you kind of get to see the fit of them. So just for your information, on the left hand side we have two codes here. We actually changed the system in DCU. The code on the right is the new system, but obviously a lot of paperwork and general conversation uses the old code because it's been around for the last 20 years. So the new code is generally what you would probably see in most activities. So as I said, there's core modules that are intertwined in the program. The core module that is across all programs or across all the majors is research practice and methodology, and this again just enables your capability around managing data, understanding data, applying data in relation to the scientific method, and also involves statistics and certain tools and techniques in relation to how to develop a real problem or a real solution from a problem using methodologies that are useful, we'll say, from an engineering perspective. And again, we follow the scientific method, which again gives you redundancy and precision in relation to scientific outcome or validating a problem or validating a result. We then so then you go into optional modules, and there's many here. So we have everything from finite element analysis, heat and mass transfer, engineering management, manufacturing system simulation, surface engineering tribology. That's crossed out this year because it just happened not to run this year, but it may run next year. Manufacturing simulation, system simulation, energy system decarbonization, energy auditing, and energy management. And actually, just there, the semester 1 modules. Obviously, you don't take them all; you take a select of those, and then semester 2 modules again build you up into advanced finite element analysis, computational thermofluid dynamics, manufacturing processes, entrepreneurship for engineers, advanced sustainable energy systems, whole life cycle analysis, turbo machinery, and global sustainable development challenges. So you can see the mix of sustainability, engineering, modules here, CAM modules, advanced simulation modules, and effectively these, the whole idea here is that the student chooses what module that suits them. And then so we have year-long modules, and these are related to the biomedical major. And again, just some focus here really is that these are currently year-long modules, and these modules are also on campus. So we'll talk about actually on campus and remote activities as I go through this as well. Generally, the majority of these modules in semester 2 and semester 1, we advise and we have the capability for many of these modules to be online, recorded, and then some of them are synchronous, so that basically they're presented in class online at the same time. They're also recorded, and they're also then the recording is put up on Loop, which is a platform for teaching that you have access to. So that allows people who are within the country, but not necessarily in DCU every day, to actually access the information, engage live online with the lecture, or actually see the recording of it that evening, that weekend, and then engage with it with the lecturer then maybe on questions via email or via the Loop platform that I just mentioned. Okay, so the core modules effectively, the project is a core element of the master's programs across all the majors, and effectively it's a year-long project. We effectively started in September, but really the most activity happens from January right through till August. And at the moment, we're actually currently changing a little bit to actually give you the projects in January rather than in September, to actually just manage time for students a little bit better. So the project is aimed to start in January from next year on, where students then are assigned a project, or you can choose a project, develop it with a staff member, and then propose that project. And this is where students at a master's level really come into their own, because they can actually have really interest in a topic. They can develop their own idea in conjunction with their supervisor, and then really come out with a really fantastic piece of work that they can then show within their CV. They can discuss in interviews, and really that's what really can be very strategic about the master program. If you want to get into a certain area, whether it's aviation, whether it's transport, whether it's energy, whether it's a specific company or industry that you like, if you tailor your project to that, you also have then the major connected with that. You're very likely that your CV will stand out in the plethora of all the rest of the CVs for a particular role. So depending on the major you choose, the project is slightly different. So obviously, if you're doing a project, if your major is in sustainability, your project probably needs to be in sustainability at some element. If your major is in biomedical, your project will be in biomedical. And if your major is in advanced manufacturing, your project's in advanced manufacturing, the same as simulation-driven design. If you haven't chosen a major, you can actually do a project in anything. And then your project effectively is a project in mechanical manufacturing engineering with no major. But you can, because it's general, you can have any topic you want. So again, lots of information will be given to you that when you start DCU. Okay, so I just went through the majors again, just for your information. There's either the general major, or sort of general exit, as in just the master's in mechanical manufacturing engineering, or else there's a master in mechanical and manufacturing engineering with either simulation-driven design, advanced manufacturing, sustainable systems and energy, or biomedical engineering. So actually, I'm just going to actually stop there for a moment. So we've talked about the modules. We've talked about the program. What I want to talk about then is just the if you don't choose a major, the only requirements really from a module perspective are the research practice methodology and your project, and you can choose any module you want then from the list of modules that are presented in semester 1, semester 2. And again, some students find this really useful because they pick a mix, and then other students really want to come out with a major in a certain area, so that's why they choose. So what I want to do is just go into each of the majors then in relation to very specifics. So if you have no major, you choose these two modules, and then any of the rest. If you choose a major in simulation-driven design, you have your core modules that you have to take, and then effectively with those and others that you can join in as well if you want, you get your masters. So you have your core module, which is research practice methodology, and then again simulation-driven design. You'd expect some sort of simulation, turbo machinery, finite element analysis, computational fluid dynamics, and then you have your project. So again, these end up being the modules that really connect with this major. To get the full 90 credits, however, you select 3 other modules from the list of modules other than these. So you could tie in this with more CAM, mechanical engineering based modules, or if you have an interest in sustainability, you could tie that in with sustainability modules. But the fact that you come up with a major in simulation driven design with an angle in something else, and again, that can be very appealing for employers looking at students' experience, knowledge, CV, etc. Advanced manufacturing, as you'd expect, the manufacturing element is more pronounced. Manufacturing system simulation, manufacturing processes, your project in advanced manufacturing, and then you've surface engineering, tribology, management, economic analysis, and then obviously the core module of research practice methodology. And again, you select 4 more modules in this case from the list of modules. And then you could tie that advanced manufacturing with simulation-driven modules if you see fit. So the major in sustainable systems and energy, again, you'd expect these to be more on the sustainable side. So on technology around sustainability, on knowledge around the effects of climate change, and then also in relation to policy and governance and that element. And again, you have the core module of research practice and methodology. So again, and then you select other modules to accommodate the 90 credits that you need. And then the biomedical exit, as you'd expect, you have some basic engineering modules, but then you also have the biomedical elements to kind of really just ensure that you have the knowledge around biomedical engineering from its theory, its practice. And again, the biomedical side does have a bit of a bit of lab work, long semester-long modules, etc. And again, tying that in with other elements within the modules you can choose from, people or students like that as well, that they can actually bring in maybe a bit of advanced manufacturing into biomedical engineering major. So the idea for full-time students is that within the first, it's for full-time students taught modules, it's a 1-year program. So really it starts in September and runs right through to August. And you effectively do 30 credits in semester 1, 30 credits semester 2, and 30 credit of a project in semester 2 from next year on. And that gives you your 90 credits, which then you have a master's in mechanical manufacturing engineering with maybe a potential major that you've chosen. In relation to part-time, the typical idea of part-time, so students are allowed to do part-time. And the idea then is that you have less credits in semester 1, semester 2. Maybe in the first year you have 2 credits in each semester, and then the second year then you have maybe two more modules in each semester. But then you have to do your project, and the project can't be done across 2 years or 3 years. It has to be done across a 1 year or less period. And we'd advise then that the project we've done in the final year of the part-time. So I'm nearly finished, so I'll go on to the exit awards. So the normal exit obviously is that if you so all our credits of each module is 7.5, and we basically students generally take 8 of those at that level. 7.5 credits is a level 9 module. So 8 of those brings you up to 60, and then your project then is 30 credits. So that totals 90 credits. An alternative exit. So sometimes what happens is students come in, they do it full time. And maybe after the first year, they maybe have I know they've got a job that they really like, and they don't want to finish the masters, so they've effectively gained a number of credits. So then effectively they can just exit with a number of credits, and if you get 60 credits, you can exit with a graduate diploma in mechanical manufacturing engineering with a major in. And then if you only get 30 credits, you can exit with a graduate certificate in mechanical manufacturing engineering with a major in. And again, the graduate diploma and graduate certificate generally do not require a project, but the credits, you can have your project obviously in a number of modules. So it depends on the situation with the student, and these would go through effectively exam boards where we would allow the student to exit if that's what the student required. Obviously, there is a certain time period to produce a master's in DCU, and after a number of years, if a student is constantly repeating modules, they can't repeat them infinitely, and students are asked to exit the program if there's a number of issues with repeated exams, etc. So students can exit. If they've done credits, we're happy to give them an award. And then the other option, just because I am the program chair for these as well, so I'm the program chair for the graduate diploma and the graduate certificate as well. So students actually can enter DCU on the graduate diploma track as well. This has been funded for the last 5 years, so that's an option to come into DCU just directly into a graduate diploma. Again, if you don't do all the credits, you may exit with a graduate certificate, but actually coming into the university with a graduate diploma, you can actually migrate then to the master's program. So again, students do that. We have a handful every year that do that. And again, that is an option. I've talked through the Access course very basic at the very start. So basically, students that do not have a primary degree in mechanical manufacturing and engineering, it's good to come in on the Access course. There's a pass rate of 50 within that, because we want students to have the level. And again, within the Access course, the whole idea here is that you're building up your engineering basics in maths, manufacturing processes, mechanics and machines, etc., and thermal fluids. So again, building up that knowledge. And again, this is a year-long course for the students. And then once they've done that, they apply for the masters and they can enter. The qualifier B then again is for mechanical and manufacturing engineering that don't have the enough qualification at level 8, and these are 30 credits to build up the knowledge, and then basically must pass down at a 50% rate as well, and effectively then that you do that for a year, and then you can join the master's course program after that. So this is just a kind of a timeline of the qualifier B entry, if students are interested in that. Okay, so that's me, and I'll stop share.